Hello, ladies and gentlemen. This is Friction Notes Part 2, and I am Mr. Hunter. So last time we talked about the free body diagrams and the situations in which you have friction and kind of what the forces are doing and how it looks. So today I'm going to start breaking down the equations and what you should do when solving for friction. The key equation that we have is force of friction equals mu times force normal. And please remember that mu is just the stickiness of the surfaces. It's the coefficient of friction. You can find it on the front of your reference tables, or sometimes you have to figure it out. We also remember that force normal, because it's equal and opposite to the force due to gravity, equals the force due to gravity. So on a flat surface, force normal is mass times acceleration due to gravity. And once again, on a flat surface. So now we're going to move into more of the application of the situations. So remember, as I said in class, this is what people find difficult. They find physics difficult because you actually have to apply what you're learning to new and various situations. And that's why people are like, physics is hard. It's not really, it's just a way of thinking that you have to get accustomed to. Like when you play soccer for the first time or play an instrument for the first time. It's difficult because you haven't learned the kinematics of it or the style of it, but once you start practicing and practicing and practicing more, you get used to it. So, friction between surfaces. There are two ways to solve for friction, and so I'm going to give you kind of like hints and what to look for when solving for friction, okay? So, one is you want to look for what the object is doing. And so one key thing that they can give you is they can give you the types of surfaces, types of surfaces. Another thing that they can give you is constant velocity, which I won't write because I have it there. They can actually give you acceleration and say, hey, find the force due to friction. So let's look at different situations, right? So just like the example I gave you this morning, where I said a 10 Newton steel box is sliding at constant velocity on a steel floor, find the force due to friction. Your hint was there is that they gave you the type of surfaces. If they give you the type of surfaces, they give you mu, and either sometimes they give you mu directly, or you need to go look on your reference table to figure it out. So let's give you some examples in some situations. Like let's say that a box is not moving, right? And it's a 10-kilogram box, and it's not moving, but I'm pushing it with 60 newtons of force, but it's not moving. Well, according to Newton's first law, if the box is not moving, so V equals 0 meters per second, since the box is not moving, my force due to friction has to equal 60 newtons. And then I could say, hey, find mu, right? Well, if I want to find mu, I know that force of friction equals mu times force normal, and we're on a flat surface, so this is mass times acceleration due to gravity times mu equals force due to friction. And since the box is not moving, and hint, hint here, I can also say the box is moving at constant velocity and being pushed with 60 newtons, those two situations, you'd have to solve it the same way like I'm solving it now. So in this case, I want to find mu. I don't know it. But I do know the mass of the box. The mass of the box is 10. I know that acceleration due to gravity is 9.8. I don't know mu, but I know that force due to friction is 60. So 10 times 9.8 is just 98. So I divide out by 98. That cancels. Divide by 98. And I got mu equal to, I believe it is 0.8. I don't have a calculator right in front of me, so I'm pulling out my cell phone. So 60 divided by 9.8. Oh, sorry, 98 is, my bad, 0.612. So we get a mu of 0.612. And remember, it's a coefficient because I have newtons divided by Newton, so the Newtons knock each other out. So this is when the object is at rest. So here I'm at rest. Or it's the same thing as if I'm constant velocity. So I could be at constant v or at rest, and this situation will occur where I can say, hey, find the force due to friction. In this case, I didn't give you the type of surface because I said find mu, so I'm asking for that, but I told you that, hey, it's moving at constant velocity or it's at rest. So actually, let's look at the math when we have constant velocity or acceleration. When that's the case, when they don't give you the type of surface, or so they give you the type of first surface, or they give you the force pull or the force of friction. If they give you those, typically you're going to use the F force of friction equals mu Fn. Okay, so that's a heads up. Like, you have to read the problem. What are they asking me for? What do they give? And what do I have? And that tells you which situation to use. Now we jump into Fnet with constant velocity or acceleration. So I have Fnet equals ma. Now, if the problem doesn't say, hey, your Fnet or your unbalanced forces equal this, you have to assume that your force push minus is your force of friction equals mass times acceleration. The definition of force net is the sum of all the forces on the same plane. Once again, just like I said in class, if you're confused, draw a picture. Because if I have a force that is pushing this way, I'm going to have some frictional force going the other direction, right? So in this case, I can give you acceleration, I can give you mass, and I can give you the force to push and say, hey, solve for the force of friction. Or I could say there's no acceleration. If there's no acceleration, this problem becomes really easy. If A equals 0 meters per second squared, this problem becomes really simple because force of the pull minus my force due to friction equals 0. So now it's just a simple algebraic equation where I'm just solving for one of the sides. So let's say I'm solving for force of friction. Force pull. I have to add the force of friction to the other side. That goes to 0. I have force of the pull equals my force due to friction. That's easy. That's constant velocity. It's the same concept of why we were doing this as well. Constant velocity or 0 meters per second. Now, when I have acceleration, I once again need to remember that I got to kind of forget Fnet and saying Fnet, because usually you'll just put Fnet and keep it moving, and you'll be like, well, I don't know my force of friction because you never put it in your equation. So instead of saying Fnet, you got to break it down. It's the force push minus my force due to friction equals my mass times acceleration. So if I say, hey, my acceleration is 2 meters per second squared, and I have a box that is 10 kilograms, I know that its unbalanced force is going to be 20. So let's say I'm pushing with 25 newtons. And I said, hey, find the force due to friction. And I'm skipping LEPA for the sake of time. So I have 25 minus my force due to friction equals 20. So now I got to solve. So I got to subtract 25 from both sides, subtract 25 from both sides, and I get a force of friction. Negative force of friction equals -5 newtons. And then I got to bring the negative over, I get a force of friction equal to 5 newtons. So once again, it's an application of the law. I've learned what it is. Now I have to figure out the situation that I have and find the appropriate variable. So a few things really quick that you guys are still struggling with, so I'm going to address. Newton equals a force. When I say I have a 10 Newton box, this means that this value right here is the force due to gravity, which, as we said, on a flat surface equals my force normal because it's equal and opposite. So that is my force. That is my Fn when they say I have a 10 Newton box, because that is your determining factor. Now, if I said I had a 10 kilogram box, this is the box's mass because it's in kilograms. In order to get its force normal, I have to mass times acceleration due to gravity is 10 times 9.8, which would equal 98 newtons. The box's weight equals 98 newtons. Ladies and gentlemen, my major concern with what I'm seeing in class is that you're not thinking about what you're doing. You're just writing numbers down and plugging them in and saying, magic wave of hands, here's my answer. And that's terribly wrong because you're not using your brains. So please read what you have. If they say you have a 10 kilogram mass and you know you need a force of friction, then you know you're going to need to get the weight of the box. If they tell you already it's already newtons, they've already told you its weight. So I will see you in class.